Linear and quadratic functions, and this one we're going to be focusing on linear functions and then a small introduction into quadratic functions. Linear function f of one variable, say the variable x, is any function that can be written in the form f of x equals ax plus b, where a and b are real numbers. If a is not equal to 0, a function f of x equals ax plus b is also called a first degree function. Now if you remember, back whenever you learned about linear equations, you learned y equals mx plus b. Well, that's pretty much the same thing that we have here. This is your slope, and this is your y-intercept. So what they're asking us to do in this first problem is to just graph this linear function. Well, before we graph it, we could actually reduce it and make our lives a tad bit easier. So let's say we have f of x equals 3 plus 6x all over 3. That's the same thing as 3 over 3 plus 6x over 3. Well, that's 1 plus 2x, which is the same thing as 2x plus 1. So this first function is the same thing as f of x equals 2x plus 1. And in this function, your y-intercept is 0, 1, and your slope is 2, or 2 over 1. So let's see if we can graph this one. We're going to graph our y-intercept, and then we're going to go rise 2, run 1. Rise 2, run 1. So now all we need to do is draw that line. There we go. This is the line, or the graph of the function f of x. Now what if we wanted to graph the function g of x equals negative 2? Well, remember, your function notation is actually just the same thing as y. So that means y equals negative 2. Well, what kind of line do we have at y equals negative 2? That would be here. We need a horizontal line right there at y equals negative 2. So this is the graph of the function g of x. Now quadratic functions, or second degree functions of f in one variable, say the variable x, is any function that can be written in the form f of x equals ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. Well, I'm sure you know this already, but for a quadratic function, your highest degree is always going to be a 2. That's how you know that it's quadratic. And this is a graph of a parabola. That's P-A-R-A-B-O-L-A. This is a parabola, and that's the shape of a graph whenever you're graphing a quadratic function. This is what we call the parent function. You can base pretty much all other quadratic functions off of the shape of this one. There are different ways that you can know what your graph is going to do without actually plotting points or anything like that. For example, remember your parent function was y equals x squared, or f of x equals x squared. Well, compare this one to that parent function. The only thing that's different is right here, this minus 4 inside the function. Do you notice how it's inside these parentheses? Well, that just means it's going to shift to the right 4 units. If you remember, the parent function is over here this way. Well, this minus 4 took this same shape and just shifted 4 units to the right. So if you had a plus 6 on the inside of the function, that would actually shift your function to the left 6 units. So a way that you can remember it is, if you add or subtract on the inside of the function, it will shift left or right, and it's kind of the opposite of what you think. If it's minus, you go right. If it's plus, you go left. Then we have a vertical shift. This happens if you add or subtract on the outside of the function. See, this one says plus 5. That just took this graph and shifted up 5 units. So if it's outside the function, See, this 5 is not being squared. If it's outside the function, it will shift up or down, and it'll do exactly what it says. Plus 5 means up 5. Minus 2 means down 2. Then we have some stretching, shrinking, and reflecting. If you multiply your function by a number that's greater than 1, see this 3 right here? We're multiplying our x squared by this number which is greater than 1. What's going to happen is it's going to stretch this. It's going to stretch it vertically, and it's going to get tall and skinny. So this is a vertical stretch. Okay? Now, if you were to multiply your function by just a fraction, don't look at the negative right now. We'll get to that in just a minute. But a fraction between 0 and 1. So let's call this fraction, let's call it b. So if 0 is less than b, which is less than 1, what's going to happen is it's going to shrink the function. I think about it as stretching it horizontally when it really just shrinks it. It makes it short and fat. So let's write that one in there. This makes it shrink. I'm going to write this also, but I don't want it to confuse you later. It's a horizontal stretch. It just makes it short and fat. Now the reason that this graph is upside down is because if you have a negative in front of your function, it will reflect it over the x-axis. So if this had been a negative 3, it would have been upside down and tall and skinny. So it would have still been stretched vertically. It would have just been reflected over the x-axis.